right, so here's our new function. F of x is equal to -3 sine of x. So instead of me just telling you what that -3 is going to do, let's look at the graph. Compare. Okay, anytime they're asking you, what's different about this, compare it to the original. So I've got sine of x right here. I'm going to put in -3 sine of x in a different color. So y'all tell me, what differences do you see here? Okay, it's definitely stretched. The green one is definitely taller than the black one. What else? There's nothing else different. Okay, both of them do go through the origin. So the black one, from the origin, when we go to the right, it goes up. The green one, when we leave the origin and go to the right, it goes down. So it looks like it's been reflected over the x-axis. So those are the two things that are going on here. The negative reflects over the x-axis. And the 3 changes our amplitude. Our amplitude is now 3. Yes, that is a vertical stretch. They may ask it in those terms. Okay, it is also a vertical stretch, but in our trig-specific terms, we do have an amplitude of 3. Okay, now, did the period change? Nope. Okay, if we look at our starting point, get back to our starting point and start the pattern over, still goes from 0 to 2 pi, so the period did not change. Our midline did not change. So the only thing that changed for this one was the amplitude. So let me just make a note over here to the side. Period is still 2 pi. And midline is still y equals 0. Those did not change. All right, let's look at a cosine example. We've got cosine of 3 over 4x. Whoops, make sure the x is in the right place. All right, so let's look at what's different about this. Did the amplitude change? Is it taller than it was before? Nope, same height. Okay, actually, this point right here is exactly the same for both of them. But our minimum, we still have the same minimum value, so the amplitude did not change. How about the midline? Did the midline change? Nope, the x-axis is still cutting that in half. So what did change? The period. You can obviously see that the green function is stretched out horizontally. So let's look at standard period. Okay, one complete cycle is 2 pi. Let's look at it on the green function. Okay, we start at 0. We get to the end of that first cycle. We start over again. Where is it? 8 pi over 3. So this one, the period changed to 8 pi over 3. And that's because of the 3 over 4. There is a way to calculate that, but I really think you're better off just looking at the graph to figure that out. Again, let's just make note that the amplitude did not change. The amplitude of this one is the standard of 1, and the midline did not change. It's still the standard of y equals 0. Any questions so far? Okay, what do you think is going to happen next? Okay, going back to sine, and this equation is sine of x plus 2.5. Notice I did not put any extra parentheses. I just typed it in exactly how it looks on the paper. So what's happened to this one? It's just been moved up, right? Period hasn't changed. Okay, everything is still happening in the same place. It doesn't look like the height has changed at all, but the midline has changed. What do you think the midline has changed to? 2.5. How can we check it? Graph the line y equals 2.5 and make sure that it goes right in the middle of your trig function, and it does. Now, also by doing that, you can check your amplitude. If you know the midline's 2.5, your maximum's 3.5, that's a distance of 1, right? So this one, the plus 2.5, changes our midline to y equals 2.5. Our period did not change. It's the standard 2 pi. And our amplitude did not change. It's the standard 1. So we're going to graph this one, but let's go ahead and see what we can maybe fill out before we graph it. Okay, so midline. What do you think the midline is going to be of this last example? -3. Okay, what do you think the amplitude is going to be? 2. Okay, amplitude is 2. Period, that one's a little tricky. Let's just look at since I didn't show you how to calculate it, let's actually look at the graph. Okay, so we're going back to cosine. Let me get all the rest of this stuff out of the way. It's 2 cosine of 4. Now, they used a theta instead of an x. Technically, you could put an x, or if you type the word theta, it will put that variable in there. -3. Okay, 4 theta minus 3. Okay, so let's check our line. It said that it was going to be y equals -3. That would appear as if it goes through the middle of our function here, so that checks out. Our midline is y equals -3. Let's look at a minimum, -5, a maximum's -1, so 2 units this way, 2 units that way, so our amplitude is 2. Let's check our period. Well, let's figure out what the period is. Okay, starting point 0, go all the way through 1 complete cycle. My point is in the way. Okay, 1 complete cycle ends at pi over 2. So the period here is pi over 2, so it's shorter. This one up here got longer. 8 pi over 3 is longer than 2 pi. This one is shorter. It's exactly, what, a fourth of the standard? The standard is 2 pi. Okay. One more thing I want you to notice. We've got time. One more thing I want you to notice. If we start here and go to 2 pi, how many cycles did we complete on the green one? How many cycles were completed by the time we got to 2 pi? 4. Look at the number in the equation. 4. That many cycles are completed in the standard 2 pi. If we went back to this one, in the standard 2 pi, we would have gotten 3/4 of the way. That was a little bit harder to see. We would have gotten 3/4 of the way through a cycle on this one by the time we got to 2 pi. Okay, we will practice